Are we recording?
Mhm. Okay. All right, we'll go ahead and start. Apologize for being late. All right, but on Monday, we did talk about what began section 7.1 dealing with representing and creating functions. We talked about what a function is and how it is as a special relation. We define what a function is. That means from set A to set B, each element of A corresponds to exactly one element of B. Okay. Then we talk about function notation, which is of course f of x. It can also be g of x or h of x. Now, I think I did an example that is related to a function. And also, we did some examples here. I know we did this one where we had to kind of do a little bit of algebra there. Okay, so problem number 31 is what I'm going to pick up with. Okay, and that is one has 5 more than 4 times as many stamps than Angel. And here I'm going to let A represent the number of stamps Angel has, and let J represent the number of stamps 1 has. And here I want to write a function that expresses the number of stamps 1 has. Okay, so we're letting A represent the number of stamps Angel has. And of course, J is going to be the number of stamps that 1 has. So in this case here, we want to write a function that expresses the number of stamps 1 has. Okay, so that's going to be J. That's going to be equal to, now we need to write this or express this as an algebraic expression. So in this case here, 1 has 5 more than. Well, 5, of course, that's the number 5. The word more than as a operation or mathematical operation means plus. 4 times as many stamps as Angel. So that's going to be 4 times the number of stamps Angel has. That will be A. So in this case here, this will be J is equal to, go ahead, someone's showing up. Okay. This will be J is equal to 5 plus 4A. That's part A. Writing this as a function. And part B, suppose Angel has 68 stamps. How many stamps does 1 have? And you're going to use this function in part A to solve this problem. Okay, so in this case here, Angel has 68 stamps. So we're letting A equal 68 because we let A be the number of stamps that's 1 has. I mean, Angel has. So to find the number of stamps that 1 has, we take that function, J is equal to 5 plus 4 times, and just substitute the A for 68. Okay. Let's here 4 times 68, that's going to be 272. And then 272 plus the 5 will be 277. So in this case here, 1 has 277 stamps. All right, any questions on part B? Okay. And now part C. Part C is this: can 1 have 135 stamps? Can 1 have 135 stamps? So that means J is 135. So we're going to let J be 135. So we're going to use part A. We're going to substitute the J with 135. So we got 135 is equal to 5 plus 4A. Now we're going to solve this equation for A. That means we need to subtract 5 on both sides to get 130 is equal to 4 times A. And then if I divide both sides by 4, that means that A is going to be equal to how much?
32.5.
Okay. Can someone have half of a stamp? No. Okay. And by the way, by looking at this, when I got to 130 is equal to 4 times A, I pretty much know that 130 cannot be a multiple of 4. Okay. So in this case here, 1 cannot have 135 stamps. Okay. All right, any questions about problem number 31? Okay. Okay, let's look at this one, problem number 40. And I need to, now if you would let me, okay, here we go. And that's this. A rectangular garden with an area of 36 square meters has length L meters and width W meters. Express the perimeter of the rectangular garden as a function of the width. Okay. There are a couple of things we need to know. We need to know the area of the formula for the area of any rectangular object. And that's this: A is equal to length times width. A is equal to L times W. And then also we need to know the perimeter, the formula for finding the perimeter of any rectangular object. That's going to be 2 times the length plus 2 times the width. Okay. All right, now we're told we have an area of 36 square meters. So using A is equal to L times W, that A, I'm going to replace that with 36. And that's equal to L times W. Okay. Now they told me to express the perimeter as a function of the width. So with this one, 36 is equal to L times W. I need to solve for W first. It's multiplied by L So we need to divide both sides by L. So that means W is just going to be 36 divided by L. Then the next step would be to take this expression 36 over L, which is what W is equal to, and substitute it. No, not that. Okay, I did this wrong. I need to solve for, actually I need to solve for W. So that way I can put this in terms of W. Wait a minute. Solve for L. So I need to divide W on both sides. So this is L is equal to 36 over W. And then this will be substituted for L. So this will be 2 times L, which is 36 over W, plus 2W. So P would be equal to, if I multiply 2 times 36 over W, well, this is like 2 over 1. So 2 times 36 is 72 over 1 times W, which is W. Okay, and this will be your function in terms of the width. And sometimes they write this as P of W. Okay. All right. Any questions about problem number 40?
Why did it have to be the L that you solved for instead of the W?
Yeah, because this whole thing for the perimeter has to be as a function with nothing but W. So I need to solve for L. Yeah.
Oh, got it.
Okay. All right. Any other questions? And for those of you who are on Zoom, chime in if you have any questions if necessary. Okay. All right, here's the next one. The volume of a cylinder with radius W and height H is, that formula B of R comma H is equal to pi times the radius squared times the height, or just simply pi r squared times H. This is an example of a function that has 2 inputs and 1 output. In other words, you need to know what the radius is and the height to get the volume. Okay. So now, what is the volume of the cylinder that has a radius that has a radius of 3 centimeters and a height of 7 centimeters? And then in part B, you're going to use the function notation to express the height of the cylinder as a function of the volume and radius. Okay. So now, that's the formula that we're going to be using. And we have a radius of 3 centimeters, so that R is going to be 3. The height is 7. So all we do this is substitute R and H with those values. R is 3, so this will be pi times 3 squared times the height, which is 7. Okay. And you're gonna have to excuse me because I need to see how they want this answer. And also, to be honest with you, in my math lab, in WebAssign, sometimes they make want their answer different as well. They want this to the nearest whole number. Okay. Pi, of course, is 3.14 times 3 squared, that's 9, times 7. So in this case, now if they want that to the nearest whole number, what would that be? 198. And they want this in centimeters, so it's cubic centimeters, because volume is in cubic units. Okay. All right, any questions on part A? I think in WebAssign, they may have the units already there. Mhm. Any other questions? Okay, now in part B, using function notation, express the height of the cylinder as a function of the volume and the radius. So here I'm going to write like this. Okay. So here they want you to express the height of the cylinder. In other words, they want that H by itself. So here they want the H by itself. We need to solve this for H. Okay. And we're multiplying by pi r squared. We're going to divide both sides by pi r squared. Okay. This will be. Now, if we were to write that as a function where H is this, they would say H of B and R. And it'd be equal to this. All right. Any questions about problem number 43? Okay. Now let's say we had this. A rental car company charges $100 to rent a car for 1 week, plus 20 cents per mile after 300 miles. Determine the total cost for renting a car for 1 week and traveling in part A, 500 miles, and in part B, 720 miles. Okay. So we need to come up with a function that relates to the cost of the car, the rental cost. I'm gonna let M be the number of miles. So rental car company charges $100 to rent a car for 1 week. And then plus 20 cents for each mile after 300 miles. Okay. So if it's over 300, then that means we need to subtract the number of miles minus 300. Okay, so here I want to determine the cost of the car for 1 week. And let's say that we travel 500 miles. This is part A. So M is going to be 500. So we just substitute into that formula. C of 500 is equal to 100 plus 0.20 times, and M is 500 minus 300. So 500 minus 300, that's 200. And then 0.20 times 200, that's 40. And then 100 plus 40 is 140. So that cost would be $140 for someone who rents a car for 1 week and travels 500 miles. Any questions about part A? Okay. Part B is 720 miles. So in this case, for 720 miles, that's C of 720, that's equal to 100 plus 0.20 times the difference of 720 and 300. So this is 0.20 times 720 minus 300, that's 420. I'm gonna skip this step of just doing 100 plus 0.20 times 400, 20. That's how much, 184? For someone who rents a car for 1 week and travels 720 miles, the cost would be $184. Okay. Any questions about problem number 46? Okay. move this up, because that's what it is, just translating among representations. That's the next thing we'll look at. And these are just the NCTM standards. All right, this map represents the various representation that are in rules or in words as a table, an equation, and as a graph. So here you can see the one that's in pink is the rule that is in words. Kathy ran 3 miles less than 4 times as far as Dan. Now that can be represented as an equation, which is in the green box here. We'll let C be Kathy and D be Dan. 3 miles less than 4 times as far as Dan, that would be 4D minus 3. Or as a function, C of D is equal to 4D minus 3. And also, we can see that it's as a table, where they pick D as the distance that Dan traveled, and C would be Kathy's distance, okay? And also, if you look at the bottom, you'll see that it can be represented as a graph. They probably took these data values here as ordered pairs and plot them on a coordinate plane, like 1, 1 to the right, 1 and up 1, and then 2, 5 will be to the right, 2 and up 5. And those represents the fact that if Dan traveled 1 mile, Kathy traveled 1 mile. Or if Dan traveled 2 miles, Kathy traveled 5 miles, and so on. Okay. Now, in this next example, it requires students to translate among various representations to solve problems, like this one. The graph shows the total cost in dollars, which is C, that a customer pays for N pounds of coffee from an online coffee merchant. The total cost includes a fixed fee for shipping. And here's what that graph looks like. Okay. Now, to answer the questions based on that graph, they're right here. What does the order pair 2, 13 mean? And here's what that answer is. An order of 2 pounds of coffee will cost $13. Okay, so that's what that ordered pair means. Because if we go back to that graph, you'll see the number of pounds of coffee, that's going to be the horizontal axis. The total cost is the vertical axis. So for 2 pounds of coffee, that point right there represents the number of pounds to cost. 2 pounds cost $13. And then the next question is, how much does it cost to order 4 pounds of coffee? Now we can get that from the graph as well. So here, if we look at that graph, 4 pounds of coffee, that's your N, it'd be $23 because that point is halfway between 22 and 24. So here, that represents $23 for 4 pounds of coffee. And then in part C, Carolyn paid $18 for an order. How many pounds of coffee did she order? Okay. Let's see, $18. That's the total cost. That's going to be this point right here. We need to find the number of pounds that it's related to, which is 3 pounds. So for $18, this person paid 3 pounds, ordered 3 pounds of coffee. All right, and now in part D, ignoring the shipping costs, how much does each pound of coffee cost? All right, now let's think about this for a moment by looking at this here. All right, let's look at this point. That cost for 1 pound of coffee is $8 total. And then for this point, for 2 pounds of coffee, it was $13. Let's look at the difference here. What's the difference between 18 and 13? Yeah, what's the difference? It's 5. So in this case here, each pound of coffee would cost $5. And we can verify that by doing this. We got 13 here. This one's 18. 13 from 18, that distance is 5. And also 18 to 23. That distance is also 5. So, excuse me, the cost was $5 for the coffee. Yeah. Okay, we're ignoring the shipping cost. So for each pound, it's going to cost $5. And the answer to part E was already given. What's the shipping cost for each order? That's going to be, of course, $3. And the way we get that, okay, if that's $5 between here and here, then if I subtract 8 from the 5, you get $3. So it costs $3 to ship. And then let's predict the cost to order 12 pounds of coffee. Okay, I'm going to go through all of these slides. To this, because that's going to lead us to this table of ordered pairs. So here, this can be generalized by this equation. Okay, that's going to be 5 times n plus 3. That's $5 for each 1 pound of coffee plus 3 for the shipping cost. So we can use that equation there to find out the cost for 12 pounds of coffee. So we just substitute the n with 12. So it'll be 5 times 12, that's 60. 60 plus 3 is $63. So the cost to order 12 pounds of coffee would be $63. Okay. All right, any questions on that particular example that I just went over? Okay. All right, let's look at problem number 48. A company makes custom shirts for local sports teams. Each shirt has a fixed price, but the company also charges a setup fee. The graph below shows the total cost for a customer that orders in shirts. So that represents the graph, as you can see, as ordered pairs. And we're going to use that to answer the next 4 questions here. What is the cost for each shirt? Okay. So let's go back to that table. I mean the graph. So we're going to find the cost for each shirt. It'd be $6 because for 1 shirt, the total cost is $15. For 2 shirts, that's going to be $21. So the distance between 15 and 21, that's going to be 6. So each shirt costs $6. Okay, that's part A. Okay, now what is the setup fee? Well, we know the cost of a shirt is $6. And for one shirt, it was 15. So if I subtract 15 minus 6, that's going to be $9. That would be the setup fee. Okay. And then part C would be to express the total cost, Y, as a function of the number of shirts in order. So that Y is equal to, that's the total cost. The number of shirts will be in. So if it's $6 per shirt, that would be 6 in. And then we add the cost of the setup fee. That's 9. So this would be the equation, Y is equal to 6 in plus 9. And if they want as a function, it would have to be this, Y of n. And then finally, part D, how much would an order of 30 shirts cost? N is the number of shirts. So 30 shirts, we just substitute N with 30. So it'd be 6 times 30 plus 9. Okay, it'd be 180 plus 9, or 189. So the cost for 30 shirts would be $189. Okay, any questions about problem number 48? Next, we'll talk about the algebra of functions, and that is creating new functions. Okay. All right, let's take a look at this function machine that I have here. A function, which is can be viewed as a machine that accepts an input called x and then produces an output f of x. The number x enters the machine, and the number f of x exits the machine. So here's the input, and this part represents the output. So there's the output right there, f of x. All right, scientific calculators have various functions such as the square root key that acts as machines. So if you enter the number 4 in the calculator and push the square root button, then the calculator will display 2, because of course the square root of 4 is 2. All right, and then next is the domain and range of many functions are going to be subsets of the set of real numbers. And if we say x belongs to the domain of f and g, we can create new functions using arithmetic operations, much like creating new sets using set operations. Okay. Now, because f of x and g of x are real numbers, we can add or subtract, multiply or divide two numbers, as long as we avoid dividing by zero, because dividing by zero is undefined. Okay. So here, these are the new functions that we can symbolize: f plus g, f minus g, f times g, and f divided by g. Okay. So these are just an example of how to evaluate the functions f plus g, f minus g, f divided times g, and f divided by g. Okay, let me do this. Okay, so these f and g are given to you. And if I want to find out what f plus g is, that's this right here, the inputs are going to be the same. To find this new output for the sum of f and g, we take the output of f and the output of g and add them together. So 4 plus this 3 gives you 7. And of course, for x, for the input being 1, we look at the outputs for 1 in f and g, like -1 plus 5. That gives us 4. And for 2, f plus g, I look at the outputs for f and for g. That's 6 plus 2, which is 8, and so on. And we do the same thing for f minus g and f times g and f divided by g. What was that again? Well, if they did, then we wouldn't be able to do f plus g, f minus g, and so on, because they have to be the same. Any other questions? Okay, because in this next example, this is problem number 50 in the text on page 381. Because here we got f and g, they are functions as defined in the table shown. And here I want to complete those tables for those functions, f plus g, f minus g, f times g, and f divided by g. Okay. So in this case, let's start with f plus g. Now the input are, of course, 1, 2, 3, 4, and 5. That's f plus g. Now, when our input is 1 and we want to find the sum of those outputs for f and g, we have to do this: add 3 and -6 together. So what's 3 plus -6? -3. And then for the output, for the input of 2, we'll look at our outputs when our inputs are 2. -4 plus 4. 0. And then for 3, we'll look at the outputs for 3. That'd be 4 from the 2 plus 2. And then for 4, the outputs of 4 are 6 and 3, which is 9. And then the outputs for 5, 8 and 4, 12. So that's our table for f plus g. And now for f minus g. So here we're going to be subtracting So for the input of 1, we look at our outputs for 1 and subtract. We do 3 minus 6. 3 minus a negative 6. Okay. So if you would positive 9, okay. And then for the for 2, we'll look at our outputs for 2. Negative 4 minus 4, which is negative 8. Negative 4 minus 4. And then for 2, for x, for the input of 3, 2 minus 2, which is 0. And then for the input of 4, 6 minus 3. That'd be 3. Then finally for 5, 8 minus 4, that'd be 4. Okay, so that's for F minus G. Now for F times G, we just multiply our outputs for those corresponding inputs. So in this case here, for the input of 1, we do 3 times negative 6. That's negative 18. And then for the input of 2, negative 4 times 4. That'd be negative 16. And then next, for the input of 3, 2 times 2. That would be 4. And then for the input of 4, this will be 6 times 3. That's 18. And then finally for the input of 5, 8 times 4. That'd be 32. And then finally F divided by G. Okay. All right, so we divide our outputs for the corresponding inputs. So for the input of 1, we do 3 divided by negative 6. It'd be negative 3 over 6. But in simplest form, it will be negative 1/2. Okay. All right, now for the input of 2, if I do negative 4 divided by 4, that's negative 1. For the input of 3, 2 divided by 2, 1. And for the input of 4, 6 divided by 3. And then finally for the input of 5, 8 divided by 4, also 2. Okay. So that's how you complete the tables for the sum, the difference, the product, and the quotient of 2 functions, F and G. Any questions on this? Okay, now on this next slide, here we go. It's just what I got through talking about. That's defines the new functions, F plus G, F minus G, F times G, and F divided by G. So here, F plus G of X is just simply adding F of X and G of X together. Then F minus G of X, that's just simply subtracting F of X minus G of X. Then F times G of X, that's just F of X times G of X multiplying the 2. And then F divided by G of X. We can write that as F of X over G of X. The condition there is where G of X cannot be equal to 0. Okay? Because dividing by 0 is undefined. Okay. So on this next slide, I don't think this is going to be in the homework, but they want you to express each rule as a combination of other rules. In other words, they want you to break each one of those apart, like f of 4x. And here it is. And the answer is going to vary. So we can do this. Make g of x equal to 4 and h of x equals to 8. That would mean f of x will be g of x times h of x. That means 4 times x would give us the 4x.
I have no idea.
Well, you know, this is not in the homework.
Okay.
So if you want me to, I can skip that.
Is it on the test? That's
No, no. But something like this might be on the test. And besides, they did tell you answers may vary, so there's no one right answer to that.
then I could come up with a wrong one now.
Well. Okay, so in this one, we got f of x equal to 4x minus 1 and g of x equal to 2x plus 1. And let's say I want to find f plus g of negative 3. So in this case here, I'm going to find f of negative 3 plus g of negative 3 using those two functions. Let's see. F of x is 4x minus 1. And if I substitute the x with negative 3, 4 times negative 3 will be negative 12. And negative 12 minus 1 would be negative 13. And then g of x is that 2x minus, plus 1. So if I substitute that x with negative 3 in g of x, 2 times negative 3 will be negative 6 plus 1, which is negative 5. And then I add these two together to get my final answer. F of negative 3 came out to be negative 13 plus g of negative 3 came out to be negative 5. Negative 13 plus negative 5 would be negative 18. Okay. Questions on part A?
So the numbers in the parentheses would be 8.
Yeah.
Okay.
Any other questions?
Okay, I'm sorry, okay.
Okay. I'm just writing this down. Oops, and this is not negative. Okay. F divided by g of 2. This just simply means f of 2 divided by g of 2. So in this case here, let's find out what f of 2 is. And f of x is 4x minus 1, so this would be 4 times 2 minus 1, which will be 8 minus 1, or 7. So f of 2 would be 7. And then g of 2, that's at 2x plus 1, so this would be 2 times 2 plus 1. This would be 4 plus 1, which would be 5. Okay. So f of 2 will be 7, that's the numerator. The denominator is g of 2. which is 5. So F divided by G of 2 would be 7/5. Questions on that? Okay. I'm gonna erase part A so I can put part C up here. Which is in this case F minus G of 0. That's F of 0 minus G of 0. So to evaluate F of 0, that's going to be 4 times 0 minus 1. And this will be 0 minus 1, ends up being -1 for F of 0. And G of 0 that'd be 2 times 0 plus 1. And this will be 0 plus 1, which is 1. So now F of 0 is -1 minus G of 0 is 1. So when I do -1 minus 1, I end up with -2. Questions on part C? And then finally part D, that's F times G of 3. So that means I need to multiply what F of 3 is and what G of 3 is. So for F of 3, substitute X with 3, this will be 4 times 3 minus 1. This will be 12 minus 1, which will be 11. And then G of 3, this will be 2x plus 1 is what G of X is. So it's 2 times 3 plus 1. 2 times 3, that's 6. 6 plus 1 will be 7. Now, F of 3 is 11 times G of 3, which is 7. So 11 times 7, that's 77. Okay. Any questions on that particular example, problem number 51? Okay. So that's going to wrap up section 7.1. And I guess that'll wrap it up for today. So, and for those of you who are Zooming, make sure that you type in your name in the chat space. So that way I know that you were here. Okay, and everybody else in here, make sure your signature is on the sign-in sheet. Okay, I'll open up the homework for section 7.1, hopefully by the end of the day. And on Monday, we'll go into section 7.2, dealing with solving equations. Okay.
Do you already have the notes on Blackboard? What they want to?
I'll post those as well by the end of the day.
Thank you very much.
All right. All right, and everybody else, on Zoom, make sure your signature, your name is posted in the chat space. So that way you'll be counted present.
No, I was just wondering about her. She wasn't even on the thing. Thank you, sir.
All right, you're welcome.
You have a great evening.
You too. Okay, remind me to change that, all right?